All right, so equations with fractions. So now, all the equations we saw before didn't have any fractions on them, but the equations may have fractions or may have even more multiple fractions, not just one. Take a look at this example, x over 3 equals 2. So we want to solve it, means we want to get the x by itself. The x is not by itself here, so what do you think we need to do here to get the x by itself? Is one operation. First, you want to see what operation is here between x and 3. What is this operation?
Division.
Division. So the opposite of division would be?
You multiply 3 to both
That's
sides.
Right. That's right. So
Multiplication.
exactly. That's right. We're going to multiply by 3 in order to cancel these 3. So we have x by itself. 2 times 3 is 6. That's a simple one. If you have only one fraction, you want to cancel a number, just multiply that by that number. Second method to do the same one is this. Let's take the same one, x over 3 equals 2. Another method to do this is what we call cross multiplying. Cross multiplying, we need to have two fractions. First, one on each side, then we can cross multiply. But this one is not a fraction, we need to make it a fraction. How do you do that?
2 over 1.
2 over 1.
That's right, just gotta put it over 1. So then we cross multiply. So you times this way, x times 1. Then 3 times 2. Notice that I'm using this dot for multiplication. It's not a decimal point, it's a dot, because I don't want to use the multiplication sign here. It looks like x, so it would look a little confusing. So this is a multiplication, it's not a decimal point. So you cross multiply this way, the other way. Once you do that, as you can see, you get rid of the fractions. They're gone now. We just need to simplify this. So this will be x and 6. As you can see, we get the same answer as before, x6 and x6. So if you prefer to do it this way, that's fine. If you want to do the cross multiplication, that's also fine. Let's look at another example. Okay, negative 2x over 5 equals 1/3. Same thing, since we have two fractions, we can cross multiply. So this will be negative 2x times 3, which will be negative 2x times 3, and then 5 times 1. This is negative 6x, and 5 here. Are we done solving?
No.
No.
One more step, which is?
Positive 6 on both sides.
No. We have a multiplication.
To divide?
Divide by?
Negative
6 and negative 6.
That's right, divide by itself, okay? Because it's a multiplication here, we want to cancel this, also divide it by negative 6. Finally, that cancels out. And we have 5 over 6. Reduce the fraction if possible. If not, that's fine. The answer could be a fraction. And that's basically our final answer. It doesn't always have to be an integer or a whole number. It could be something like this, just to reduce your fraction if possible. And when you have a minus in a fraction, you could put that minus either down, up here, or in the middle. But probably better to just put it in the middle of the fraction. It's still the same thing. It doesn't matter if you put it next to the 5, next to the 6, or the middle. It will be still the same. That's how you solve equations with one or two fractions. Basically, cross multiplication is probably the easiest way, easiest solution. You don't have to think about the common denominator or the LCD. Just cross multiply. Now, what happens if you have multiple fractions? If you have x over 5 plus 2/3, for example, and maybe 1/5. So you have multiple fractions here, not just 2 or 1, so we cannot cross multiply. So what do you think we do here to solve this equation? Does anybody have an idea on how to go about solving this?
Do you have to find the common denominator to add them
Or
no?
That's part of it. Yes, we need to find the common denominator, the least common denominator, or the LCD. Okay, so we want to cancel all these fractions. It's an equation, so we're not trying to add all these. Instead, we want to get rid of all these fractions. And once we get rid of it, all the fractions, it will turn into something like this. The equation will be something like this, and then we solve it the same way. So first you want to find your LCD, least common denominator, the least common between all these 5, 3, and 5. Once you find it, you'll see that we can easily use that to get rid of all these denominators and turn the equation into something much simpler. So what's the LCD? What's the LCD for 5, 3, and 5?
15.
15. So the LCD again is a number that all of these can go into. The least number, the smallest one, the least, that all these denominators can go into. 15 is the least one. You could also use 30, 45, but it's better and easier to use the least. That's what the L stands for, so the least common denominator. Okay, that's the first important step. Find the LCD, and it has to be the right LCD. Number 2, so instead, we want to use that LCD to cancel all these fractions. Basically, we're going to take this, again, we're going to multiply all by LCD. By all, I mean all these fractions. So let's rewrite them again. Okay, so it's very simple. All you do is take that 15 and just write it next to each fraction with a dot, meaning multiplication, also here, and also here. We're not actually multiplying, so to speak. We just write in the multiplication down. But before you multiply fractions, what is the first thing you want to do? We're not actually multiplying right now. Always reduce your fractions before multiplying them. So for example, when we multiply this, before multiplying 15 by x, you want to reduce this way. 15 by 5, that would be 3.
3.
Times whatever term you have on that side, in this case, just x. Same thing here. So before actually multiplying 15 and 2, you want to try to cancel or reduce the fractions. So we're going to do the same thing. That's 15 by 3.
That's 5.
That's right. Just bring the number, whatever number you have in the numerator here, bring it down. And finally, what do you do again here for the third one?
3.
That's right. We're going to reduce
We
this.
do 15 and 5.
That's right.
We do
By
6 to 3.
That's it. Once you do these 2 steps, you find the LCD and you reduce. The equation now is much simpler. It's very similar to what we've been doing earlier. So it's just something like this. Easy to solve 2-step equation or 3. First, now we do the actual multiplication. Now we can do the actual multiplication. Much easier to multiply now after reducing. So this would be 3x plus 10 and 3. What do you cancel next?
1. The 10. Negative 10 both sides.
Exactly. So minus 10 on both sides. That cancels. So 3x is 3 minus 10, which is?
Negative 7.
That's right. And finally, divide by 3, x is negative 7 over 3. And that's your final answer. Again, reduce the fraction if possible. If not, that's okay. Just leave it like that. All right. Does that make sense with multiple fractions? Again, find your LCD. Make sure you find the right LCD. If something is not a fraction, make it a fraction over 1. For example, if you have another term here, for example, just 7, you want to make that a fraction by putting over 1 and then making the LCD for all of them. But in this case, we don't have that term. Once you find that LCD, just write it next to each fraction. And before multiplying, just divide. 15 by 5 is 3. 15 by 3 is 5. 15 by 5 is 3, and so on. Once you do that step, you clear all the fractions at the same time. So the equation becomes much easier with no fractions. And then you follow the same steps we learned earlier. These three main steps to solve any type of equation. Okay, but before you follow these, make sure you clear all the fractions you may have. Okay, any questions, everybody? Okay, make sure everyone. Please feel free to ask if you have any questions at any time. Let's look at another one now. Let's say x plus 1 over 6 plus 1/3 and maybe make things a little more interesting. The final example here. As you can see, we have 3 fractions. Obviously, we can't cross multiply. We only cross multiply when you have 2 fractions, 1 on each side. You have 3 fractions, much like this. So what do we do first again?
And the LCD?
That's right.
Yes.
So we have-
LCD.
That's right. Whenever you have multiple fractions, could be 3, could be 6, could be 10 fractions, the exact same way. So find LCD. What do you think the LCD is?
18?
18.
Yeah, the LCD was 6, 3, and 9. Well, the least number that all of them can go into is 18. That's important. Okay, it's very important to get your the right LCD. Okay, find the right LCD here was 15. After that, what you do is you just write that LCD next to each fraction. Let me rewrite the whole thing again. Okay, just take that 18, basically just write it next to each fraction. But in this time, a dot wouldn't be enough. It's 18 times not just the x, we want to times 18 by both of them. So what do you need here?
Parentheses?
That's right.
Parentheses.
That's right. Here we didn't need parentheses, we had only one term. But if you have something times more than one term, you need to include that in parentheses, because the 18 will be multiplied by both of these, not just the x. Do we need parentheses for this one?
No.
We don't need that. Just times 1. Okay, so no need for parentheses. Do we need parentheses for the third one?
Yes.
Yes.
Yes, 18 times both of these. But again, what do we do next? Are we multiplying right now, or are we doing something else?
No. You're
Canceling out.
Exactly, that's right. So we're not distributing actually yet. It's gonna be a mess. Instead, let's clear all these fractions. So we're gonna divide here. That will be 18 by 6 will be 3, right? Times. We'll multiply in the next step, just bring the parentheses down for now. Plus, what about this one?
6.
That's right, 18 by 3, that's
6
6.
times 1.
Finally, again, before distributing, you want to clear the fractions. That will be
2.
that's right.
Parentheses.
And does it look familiar now?
Yes.
Yes.
Okay. Looks like what we've been doing earlier, something like this with all these steps. We're just going to repeat the same process. We're going to simplify each side first, move the x's to one side and the numbers on the other side, then isolate. All right, so distribute here first, so that's 3x plus 1. Please mute your mic if you have noise in the background. 6, 4x. Whoever has noise, please mute it. Okay, now we're going to combine like terms, so it's 3x plus 7, 4x minus 6. Again, we're going to move this over. We're going to move the 7 back. So 3x and minus 4x. Okay, we move this over. The sign, the positive sign changed into negative. And this positive 7 turns into a negative 7. Bring down the negative 6, 1x, or negative 1x actually. Okay, 3 minus 4 is negative 1x. Negative 13. What's the final step here?
Divide by -1.
Divided by -1.
Exactly, divided by negative 1, divided by negative 1. So x is, what is x equal to?
13. Positive 13.
That's right, very good, positive 13, and it's done. Okay, that's probably the longest one, or maybe the most complex one. As you can see, it didn't take that long. We had to rewrite it, but it's not that many steps. So again, find the LCD, cancel all those denominators using the LCD. The rest is pretty simple. Work on each side, simplify it, move the x's to one side, the number to the other, and then isolate your x. Exactly these 3 steps here after you cancel the parentheses. And that's basically how you solve your first degree equations, regardless of how many terms you have or fractions. That's basically the procedure. Remember the main steps, not the details, not the single details of each one. Again, the main steps are these. If you don't have fractions, if you do have fractions, then remember these 2 main steps. Find the LCD and use it to cancel the fractions. Okay, guys, make sense? Make sense to you?
Yes.
Yeah.
Everybody?
Yes.
Everybody on board?
Mhm.
All right, very good, very good. So you'll find, like I said, I'll repost or I'll edit and post this to Blackboard. We can rewatch it if you need to. All right, so now let's take some attendance and then we'll go to the discussion board after that to continue the discussion if you have any more questions.